Welcome to Sarder TV, an idea sharing platform founded by Russell Sarder, who's an author, investor, and the CEO of Netcom Learning and AI Certs. We're thrilled to have Eric Siegel join us today. Eric is a former professor at Columbia University, and he's the author of the book, The AI Playbook, and he's here to tell us more. Eric, thank you so much for joining us today. It's great to have you here.
Thanks so much for having me.
So, Eric, you have such an impressive background, former professor at Columbia, got your Ph.D. there. You're also the founder of Machine Learning Week, which we'll get to in a bit. Tell us a little bit more about yourself, your background, your career journey, how you got to where you are today.
Well, I grew up being really excited about AI. I had a pen pal who was a philosophy professor and a computer enthusiast in the 70s and early 80s. And I got my first computer when I was 11 in 1980. So I was like, AI, that's what it's going to be all about. Now I'm a super AI skeptic. Machine learning is real. It's extremely valuable. I'm extremely passionate about it and a real advocate. Whereas the sort of general narrative tends to overblow the capabilities when you talk about it in terms of AI. So what that brought me to was getting a PhD in computer science focused on machine learning. And then I was a professor at Columbia University, where I taught the AI and machine learning courses. And I've been an independent consultant for 20 years. The conference series, Machine Learning Week, was formerly Predictive Analytics World, and it's this June in Phoenix.
Oh, that's wonderful. And you bring up a good point, right? Artificial intelligence is sometimes used as this umbrella term, also kind of pulls in machine learning in there. Can you explain the difference between the two?
Well, machine learning learns from data to predict. So which customer is going to click, buy, lie or die, cancel their subscription, turn out to be a bad debtor, which satellite's going to run out of battery, and where's the best place to drill for oil. So this is the technology you turn to if you want to improve any and all, or virtually any and all, of your existing large-scale operations. Machine learning is also what's under the hood for generative AI, where it's automatically creating a first draft of writing or an image, video. And in that case, it's still doing the same core concept. It's learning from data to predict, but it's predicting what should the next word be or something on that level of detail while writing, or how should I change this one pixel in the next iteration while I'm rendering an image, I being the computer in that sentence. So it's really a different way of using the same underlying concept. And they're really quite different. Most of the press we see in the last couple of years around AI is on the generative AI side, but the established place is to differentiate, call it predictive AI, also known as predictive analytics. Those enterprise use cases of machine learning, that's where we've sort of had the established track record of value capture over decades at this point.
Yeah. And we'll get into some of that as we get into your book. But tell us a little bit about, the AI Playbook, which is the book we're here to talk about. What prompted you to write it? What was your inspiration there?
So I've been actively in the field of machine learning for more than 30 years. And, in the more recent couple of decades as a business consultant, running the conference series, writing books, I'm really although I originate from being an enthusiast about the technology, now I'm about capturing value with it, getting it deployed, operationalizing, getting into production so that it actually captures value. There's a great track record of doing that, but there's a greater track record of failing to do that. So it turns out that the majority of new machine learning projects fail to achieve deployment. You need a real rigorous business-focused end-to-end practice, and that's what I present in the AI Playbook. So rather than just evangelizing how great this stuff is, how it's the most general purpose, important technology, which it is, the fact that it's the coolest science, which it is, let's get past that and say, how do we make sure that we improve that track record and are capturing actual value, actually concretely improving enterprise operations with much more regularity and a better success rate with these projects. So I approach that in the book, the AI Playbook, by presenting the titular playbook, paradigm framework, a 6-step practice, running these projects end to end with a business focus so that they actually get successfully deployed.
Mm-hmm. And so what are some of the most common ways that you've seen companies use machine learning? And then I also want to hear about some of the more unconventional ways, some of the more rare ways that you've seen companies use it.
Well, probably the two sort of most leading flagship, well-trodden areas would be for targeting marketing or for credit scoring. So the FICO score is an example. It's a little different because it's a general purpose way of scoring individuals, whereas most of these use cases, the enterprise, the company uses its own internal data for its particular customer base or its prospects and their behavior to that company's particular marketing look and feel and the actual products and how those things are responded to. So it's usually more specialized, but predicting credit, basically predicting who's going to turn out to be a poor debtor. So predicting credit risk, that is to say, predicting who's going to respond to marketing for targeting direct mail, for example, predicting who's going to cancel their subscription in order to target a retention offer. That's usually called churn modeling. You're predicting who's leaving so you can try to keep them. But it's really endless. Anywhere that an enterprise has a large scale operation, and an operation of great scale consists of lots of decisions, who to approve, test, investigate, incarcerate, set up on a date, or medicate. So any and all of our large scale operations, including the ones I just listed, very much are systematically being driven by the predictions, the probabilities that are output by machine learning models.
Yeah, that's amazing. And so what are some of the more unconventional ways or things that maybe we don't even think about in our day-to-day lives?
Let's see if I can just sort of pull some free association, because I see one every couple of weeks that I've never even thought of before. You know, like at one point, Google presented at our conference on predicting which new ads are going to have poor performance. So they'll get lots of clicks, so the advertiser has to pay a lot, but then it won't convert. People will click through, but then click right back and won't stay on the web page, right? So predicting bad ads on behalf of the advertiser. As I mentioned, predicting which satellite's going to run out of battery in order to target how to maintenance, which wheel of a train is going to require maintenance, where to drill for oil. Basically, it's kind of endless. I mean, the use case, the value proposition comes from two things. What are you going to predict and what are you going to do about it? And all large scale operations essentially or generally consist of that kind of thing, where there's an operational decision over many times. Business is a numbers game, usually conducted very poorly. Most mail is junk mail. Lots of spam gets through. Lots of bad debtors get approved. Lots of fraudulent transactions get through. That's another major area, is fraud detection.
Yeah.
So what you can do now is play those numbers game more effectively and tip the odds in your favor. And tipping it even just a bit turns out to have a dramatic improvement on bottom line performance metrics.
Yeah. And you did a lot of research for your book. You have real life examples of different companies using this effectively. Can you take us through an example or a case study that you kind of studied as you were writing your book?
Yeah, sure. The book covers in pretty good detail case study for UPS. I'll describe that now. Also FICO, not so much for their credit score. In the book, I delve into their fraud detection model for payment card transactions. And I also include a couple .com stories from my own consulting practice. In my first book, Predictive Analytics, which describes how machine learning works and delivers value, that actually includes a central color table of 183 mini case studies. That is to say, just like in the title of that first book, Power to Predict Who Will Click, Buy, Lie, or Die, it's just so generally applicable across sectors and across enterprise functions. That's the nature of the beast. What are you going to predict and what are you going to do about it? In the case of UPS, they predict where there's going to be deliveries tomorrow in order to better optimize and improve the efficiency of those deliveries. So this is for the last mile, or more literally the last several miles of delivery from a shipping center into the trucks to their endpoint. So all 1,000 shipping centers in the US have this really tough optimization problem, which is, how do I allocate all of the packages that are going to have to go out for delivery tomorrow into my shipping trucks so that each truck has a relatively optimal route to cover, and then the aggregate miles and time spent by drivers tomorrow is as low as we can possibly make it, and we can improve the efficiency of delivering those packages. The problem is that at the beginning of the evening or even in the prior afternoon, when they have to start planning which package goes into which truck and actually loading them into the trucks, they only have partial information because some of the packages haven't arrived yet and they may not know about it yet. There may be different time zones. There's a lot of reasons why they don't know where all those deliveries are going to be tomorrow as soon as they'd like to. So they make predictions. They predict what delivery addresses are very likely, relatively likely to receive a delivery, and augment their known package list with those tentatively presumed delivery destinations. Now they have a more complete picture, and they can use their package assignment system more effectively, get those trucks loaded up as effectively as possible in time for delivery tomorrow. By doing that, in addition to prescribing the routes, because it's one thing to say, hey, now this truck has a well-chosen set of packages, it could deliver optimally. It doesn't mean it will deliver optimally. Generally, it's better to have the computer to tell the driver exactly where to go in the step-by-step driving directions than to let them do it. And when you combine those together, it turns out that UPS now saves 185 million miles of driving per year, $350 million, 8 million gallons of fuel, and 185,000 metric tons of emissions.
Wow. And you have several other examples as well that you share in your book. Which industries do you envision will have the most to gain by implementing machine learning into their business operations?
You know, it's hard to think of one that wouldn't benefit. The leading industries have been high tech, which is not too surprising, and financial services. But there's lots of exceptions. So a company like UPS that I just described, that's a relatively old company now, more than 100 years old. And so they weren't built on technology originally, and they really made a dramatic shift. So even while there may be forerunners in the space, if you're within an industry that doesn't include as many forerunners, the opportunity may be even more tremendous if you have the right leadership practice to actually get these things deployed.
Yeah. So, you mentioned too that a majority of machine learning projects fail to deploy for various reasons. What are some things that organizations can do to successfully apply this technology into their operations?
Well, everyone kind of knows you got to start with the business problem. What's the business objective? What problem are you trying to solve? The problem is that to the degree we kind of know that, we also very quickly forget it because we're so enraptured and seduced by the narrative of AI. How awesome it is. It's a panacea, silver bullet, solve all problems. So the first step is to eschew that, dispense with the hype, focus very clearly on a concrete use case, which is described by what's predicted, what's done about it, right? So which transactions most likely to be fraudulent? Okay, let's automatically block those payment card transactions for further authentication before we let it through. Those kinds of what's predicted, what's done about it pairs, right? That's where you have to get really concrete. But that's literally only the first out of a 6-step practice that I describe in the book that I call BizML, so the business practice for running machine learning projects. The last of the 6 steps is the culminating point if you actually get it deployed, right? That's operationalizing it. That's where the predictions that machine learning delivers actually make a difference, and you change your existing operations in some way, improving them by way of driving them with those predictions. The other sort of intermediate 4 steps are where you really need to get business practitioners, business professionals, not just data scientists, to collaborate deeply and weigh in on the details of the project, including defining the metrics, how well it's going to work, what kind of data do you need, what's the sort of general requirements of the model, how are you going to exactly integrate it so that these predictions change operations. It's not the rocket science part, it's how you use the rocket science. And along those lines, the probably bigger message that I'd like to spread and that the book covers is, yes, there needs to be sort of an understood end-to-end practice. I show it as 6 steps, but even more importantly, more fundamentally, business practitioners have got to ramp up on a very accessible, semi-technical understanding of what these projects entail, right? Not the rocket science, but how to use that rocket science so that they can collaborate and contribute to these projects. That's the main missing ingredient to improving the deployment success rate of these projects.
Are you starting to see that happen a little bit more in your consulting practice?
Yeah, absolutely. I mean,
forming these teams.
So, I've been an independent consultant now, focused on business use cases for more than 20 years. And, when I first started out, I was always kind of pitching, hey, look, there's this stuff called machine learning, or maybe we should call it predictive analytics. At the time, everyone was calling it data mining, which was even more amorphous and a bit misleading. And, I got a lot of blank stares. So the preface to my first book is like, look, if you want to understand what I do, you gotta open your mind a little bit. Data matters. Let's operate empirically. Let's apply science to business. Isn't that a good idea? So kind of evangelizing, right? The preface to my second book is like, be careful what you wish for, because now everyone's super excited about it. It's been duly evangelized, but perhaps too much. People are too excited. It's in a way we're fetishizing the core technology, and it's in a way it's like being more excited about the rocket science than the actual launch of the rocket. But if we focus on, okay, now we have this rocket, how are we going to use it? How are we going to make sure it launches correctly, that goes in the right direction, right? It's not the rocket science part. It's not under the hood of a car. It's simply how to drive a car, which does require a lot of expertise.
Yeah. So as AI and machine learning starts to get more and more sophisticated and improve, what kind of implications do you see for jobs and for, various roles and functions?
Well, I mean, I think the answer to the jobs question is kind of 2 parts. One is, where are the opportunities, and they abound. This is the wave of the future, improving operations with science. And if you're going to do that, I mean, prediction is the holy grail for driving operational decisions. Operations consist of decisions. And the way you apply science to learn from data to drive these decisions and to make predictions that drive the decisions is, by definition, machine learning. So this is where it's at. Now, you don't need to be a technical hands-on practitioner or a data scientist. As I've mentioned, we very much need business professionals. More than anything, once you've ramped up on the semi-technical understanding, which is super accessible, right? This is much more engaging, interesting, relevant, and understandable than high school algebra. It's what's predicted, what's done about it, and also how well it works, how well it's predicted. It's really arithmetic. It's a very particular kind of arithmetic, but you don't need to get under the hood. You don't necessarily need to get into the super technical weeds of what it means to learn from data. It's good to get a sense of that, just like I have a sense of how an internal combustion works in my car engine, even though I never pop the hood. But what I do know is how to steer a car, momentum, friction, the way the car operates, rules of the road, and mutual expectations of drivers. And in that sense, I'm an expert. That's why I can drive. Very much the same thing. You need a certain kind of expertise to drive machine learning projects so that they succeed. And that's the semi-technical understanding I'm talking about. Once you've ramped up on that, more than anything, it's you as a business professional that these projects need, more than any improvement in technology or increase in technical capability of the data scientists, to increase the success rate of these projects. So I think there's a great opportunity for people playing that role and for a more pervasive understanding of what it means to act on science, what it means to deploy machine learning models into operation. Of course, the other lingering question is, what does this mean economically as far as workforce disruption? And I'm not an economist, but I will say that I think that it's going to be a lot less disruptive than the general narrative would indicate. I'm not saying that there won't be any disruption, because anytime technology, and that's what computers are for, no matter what you're using them for, they're there to automate. In this case, the core technology is the automation of learning from data, because there's so much data, a person's not going to manually go through it. That's why it can potentially do that better. But then when you actually deploy it, that's another kind of automation. It's automatically on the fly deciding which transaction to block. It's automatically deciding which of these 1 million prospects should we include in the next marketing campaign, right? So there's always some level of automation, and there's certain degrees to which that might make things more efficient and require, for example, fewer human auditors for fraud, because the existing auditors are being fed better candidates, transactions more likely to be fraudulent. So you need less human time, less human auditors to capture and catch the same amount of fraud, for example, right? So by making things more efficient, yes, it means there's changes to the economy. Some jobs have less demand, others will increase. So there are shifts, but I don't think they're super dramatic the way that the public narrative often puts it, because that's often sort of under the hype umbrella of AI, where there's the sense that AI is going to fully automate. And that's generally around the generative AI stuff. The fact is, when you look at large language models, that's where generative AI can produce first drafts of human writing. It is uncanny. It is incredible and unprecedented what it can do, and it's very seemingly human-like. It's absolutely dazzling. And I say this as someone who worked within the natural language processing research group at Columbia for 6 years. I never thought I'd see anything like this in my lifetime. But we have to, at the same time, hold in our head, there's still a really big difference between what it can do and what a human can do. That is to say that it's not going to become autonomous for many of its designated tasks anytime soon. You always need a human in the loop. You need to review each draft that it generates. You can't just have it go directly to the customer. If it's a letter, if it's a customer interaction with a chat, it might be helping a human, but it's not autonomous. The computers are not taking over in that respect. So I think a lot of the sort of fear mongering around people losing their jobs and computers taking over white collar jobs, it's kind of silliness, and it's a way in which to hype the technology and oversell it.
So one of my questions to you was, somebody who's been in this field for so many years, sort of what your thoughts are on these large language models like ChatGPT, and how you think they are going to shape the future.
It's a strange thing, because as a nerd, I am infatuated. I think they're absolutely incredible. I mean, I was focused so much on natural language processing, computational linguistics, whatever you want to call it, when I was in graduate school. It's always been a great interest to me. So the fact that it's been able to learn as much as it has from human behavior, in this case, from human writing, is incredible. It's learned something about the meaning of words and phrases and sentences and paragraphs and entire documents to a certain degree. What does it mean to understand something? What does meaning mean, right? These are pretty subjective. But it's clearly gotten somewhere. The fact is, though, we should not confuse that with the story that it's rapidly approaching human level capabilities, which I believe far transcend even today's computer capabilities. And in fact, I would warn against interpreting what we see now as being a concrete step towards artificial humans, towards artificial general intelligence, they call it, where the computer could do anything a human could do, and it could take over a company, run it as an executive, or be the ultimate virtual assistant, or whatever it is. So with that in mind, right, it's kind of hard to know. It's very hard to predict. Right now, there's a lot of investment and bets on this technology. But at the same time, it's kind of like the play Waiting for Godot, right? We're waiting for the killer app. Now, some would argue and say, well, we have a killer app. For example, in addition to writing first drafts of human language text, it can also write first drafts of code. And lots of programmers and engineers are finding this extremely valuable for certain tasks where they ask the system to write the first draft and then they try it out and they debug it or fix it or whatever. It's only a first draft, but it really improves their productivity. Maybe it makes them twice as productive depending on their programming task. That's great, but that's not what I mean. I believe that on the national stage, the international stage, the narrative, the kind of killer app that we've been set up to expect is going to be much bigger than that. It's where the computer becomes your best friend, or at least your best virtual assistant. And it's just super autonomous. It can really just handle things in a way you would expect a person to, without needing you in the loop. It'll book a whole trip and itinerary, and it'll make all these pragmatic choices. And I believe that that is fiction. I believe that it's the novel Mary Shelley would have written if she knew about algorithms. It's often pitched as both a dystopian or a utopian vision, but either way, it's a kind of hype. So what we're left with is a thing that is very seemingly human-like and clearly great at making first drafts. Beyond that, where is the killer app? Where is the value proposition? There's a lot of ideas and a very little proof of where the value is going to come. So it should be interesting. I'm sure there'll be some surprises. But as they say, futurism will definitely be out of style within 5 years.
So then when it comes to machine learning and all the advances, you've talked a lot about all the advances that have been made. We see it in our daily lives. What do you see as next? How do you see the next phase?
Right. So, I mean, listen, anyone listening is probably clear that I have something of a bias toward predictive AI applications. Those are for existing enterprise processes and operations, like for targeting, marketing, fraud detection, credit risk management, and all those kinds of existing operations, in contrast to generative AI. Now, if I admittedly have a bias, it's more about where I believe the concrete value is. And so far, that's where all the money is, right? That's where the proven returns are, still where most of the investment is. A lot of consulting firms have a veneer of generative AI, and if you talk to them, you very quickly find out, yeah, that's how you get your foot in the door, but still, it's mostly about the predictive AI applications. I recently published a Forbes article listing 3 ways that predictive AI generally captures more value than generative AI. So let me answer your question in terms of the predictive AI side. Where I think things are headed is a certain flip of orientation. Right now, the way predictive applications are usually conceived is we have an organization, it's already successful, it's got lots of operations in sales and marketing and product development and fraud detection and fault detection, and basically when you predict, you're either finding an opportunity or a problem and you're pouncing on it. You're either to circumvent it or to exploit it, right? One way or another. That's what it means to define what's predicted and what's done about it. So what you do is you look at the organization and say, where are the best opportunities to improve efficiencies in that way? Great, but you're doing it retrospectively, sort of reactively. The organization's already operating, and now it's collecting data as a sort of byproduct of what it does, and now we're going to leverage that data and learn from it and then try to improve the operations. It's sort of a secondary thing. I think where things are going to move over the next 5 or 10 years is there'll be more and more organizations or major components of organizations that orient it the other way around. It's the intended use of machine learning is there from the get-go. The way that data is being aggregated is for the purposes of developing a model. The way operations are conceived of and organized and structured into systematic processes are conceived of as in a way that's going to make it that much more amenable and less of a hack to insert those predictions and get them to operate more effectively. So I think that it's going to become more central to the way we conceive of companies.
Yeah. And just building on that a little, there's a lot of talk about ethics and responsible AI, making sure that, those things are integrated into, various models and deployment. What are your thoughts on that? And, you know, making sure that those things are incorporated into sort of the machine learning landscape.
Yeah, I'm very interested and concerned about ethics and responsible machine learning. And in fact, I've published a dozen op-eds in the Scientific American blog and San Francisco Chronicle. Anyone interested in reading my op-eds, you can find them all at civilrightsdata.com. I just got a list there of 12 links, plus some videos that make it more friendly for some of the concepts. My biggest concern is basically in where you basically have some kind of discrimination or bias by protected groups by a model. Because when you create a predictive model from data and you're going to use it to drive operations, you're not just optimizing numbers and streamlining business, you're actually in a sense regulating, right? You're governing. The model itself is kind of a law or a policy that's now being deployed because it's making a decision of people's access to resources, housing, credit, whether you're even released from prison in the case of predictive policing. And there's lots of room there for the model to be treating people who belong to different protected classes, whether it's race, gender, national origin, differently, and in that sense be discriminatory. In some cases, literally and blatantly discriminatory to the degree the model is allowed to actually consider the protected class. So it might say, depending on the gender, let's change the risk level for this credit application, something like that, right? That's generally not done, largely because of the laws in the US, but there are exceptions. And it turns out there are machine learning experts, more specifically machine learning ethics experts, who are actually advocates for allowing that type of behavior of a predictive model. It's under the auspices of what's sometimes called rational discrimination. So I'm greatly concerned about this, where you're sort of using science and numbers to rationalize letting a computer treat people of different protected groups differently. But putting that aside, because it's not as fringe as it should be, but it's relatively fringe. Putting that aside, even if you disallow that and in that sense make the model technically colorblind, if you will, there's something called machine bias or machine learning bias. And in fact, there's a very famous, often cited ProPublica article entitled Machine Bias. And that uses predictive policing, recidivism prediction as a case study. And it turns out that amongst males, black convicts, where you're trying to predict whether they'll recidivate, will they be incarcerated again or convicted for another crime after being released. The problem is that there's something called false flags, false alarms, where it gives a high risk where it's not deserved, right? It says, hey, this person's likely to recidivate, even though they're not. And you can't avoid those errors, whether it's a computer or a person. We don't have a magic crystal ball. What we do have is systems that can predict better than guessing. That can be very valuable. But where it makes those types of grave, costly errors more often for one protected group than another, that's where we have a problem. And it can do that even though it's not explicitly discriminatory, because there are other, proxy variables depending on history and the neighborhood in which you live and all these kinds of things. So this is not about equality of outcomes, but it is about equality of errors, in my opinion. And the only way to address it would be in something analogous to affirmative action, where you actually reintroduce the protected class and calibrate it accordingly. So I think we have a great opportunity to the degree that data represents the world today, and the world today is a manifestation of historical grave injustices. We can see that now. We can see how that manifests in these error rates. It's under a spotlight, it's on the table, and we have the opportunity to adjust for it, because the same systems that serve up these predictions to improve operations can also serve up adjusted predictions that account for protected class and try to create equivalence in those grave, costly errors.
So who is it up to sort of police those errors, or, police this whole landscape of, uh, data integrity, ethics, being responsible? Is it the organizations themselves? Is it governments? Is it?
I think that question of whose responsibility is to govern algorithms, I think that might be the question of the century, because it's very much unresolved, and there's lots of conflicting narratives, right? On the one hand, everyone says, hey, the Congress people, they don't even know how to say TikTok instead of tic tac, and they don't know what an algorithm is, et cetera, right? How you expect them to catch up and govern these things? And then on the flip side, of course, you've got the very reasonable argument that companies are in the business of pursuing profits, and they've got counter incentives to govern themselves. And at the same time, in my opinion, they're very, very good at ethics theater, and that all the responsible AI jargon that they put out there that sounds so special, fairness, responsibility, et cetera, these are all very subjective words unless you really are willing to put them into concrete action and define exactly what you mean, which they generally don't. So you've kind of got two sides where there's a lack of action and a lack of understanding. So it's still the realm of activism.
Yeah, and we'll be sure to check out your op-ed articles as well. One thing you said, Eric, too, which I think is so important, is, as people who are not technical, who don't have deep expertise in this, we should all still be savvy, because this is the way things are going. So where do you suggest business professionals who, aren't technical should go? What resources should people tap to get more information and become a little bit more knowledgeable in this field, in this space?
There's not enough work out there bridging the gap, and it is the reason why I wrote the book, and also why I have an online course that's meant to sort of bridge this gap. And our conference, unlike most machine learning conference, is not only for the techies. We have the whole business / operationalization, what I call BizML, track at the conference at Machine Learning Week. In general, most content, most college courses and business MBA courses, most books that are accessible to business readers tend to be very high level, more buzzwords, a lot of hype. Most cases, it's hype, right? And when I say hype, I mean false promises, poor management of expectations. Hype isn't just a fun game, and it is fun, it's intoxicating, but it's actually really costly, because by mismanaging expectations, there will be disillusionment, right? And the baby gets thrown out with the bathwater. That's the problem, right? That's the problem when a reckoning comes. So as much fun as it can be to pontificate on the wonders of an autonomous AI, it's also fun to be realistic and amazed by what it does do. I mean, generative AI is legitimately amazing without believing that it's becoming artificial humans or able to operate at human level capabilities in general. You don't need to believe that in order to still be really excited. What was the question I'm answering now?
Well, good. I was just asking where business professionals who are not don't have deep expertise should go
in order to sound less self-aggrandizing, I would love to have a few more references besides my book and my course and my conference. But look, I'm kind of grasping at straws here, and it's disheartening to me as somebody in the field this long that there's just too much of a bifurcation. People are super in the weeds, excited about the core technology, and not bridging that tough gap to the business side, or there's people sort of speaking to the less technical audience, but in so doing it, keeping it high level, buzzword level, and hype. And there's really precious little in terms of content bridging that gap. So that hopefully will continue to change. There are a couple other books. Jeff Deal and Gerhard Pilcher wrote a book called Mining Your Business. James Taylor wrote a book called, I think, Decisioning Systems. Now I'm having a little trouble. It's about decisioning, which means how to optimize decisions of organizations. That's James Taylor, not the singer, but a colleague, a business consultant. So there are books before mine that really start to bridge this gap, but not nearly as much of an effort in that arena as there needs to be.
Yeah. So the AI Playbook and Machine Learning Week are the way to go, right?
Absolutely, yeah.
Tell me more about Machine Learning Week.
Sure. I've been running the conference series since 2009. It used to be called Predictive Analytics World. And we actually do have a new sister co-located conference, Generative AI Applications Summit. They're both the first week of June in Phoenix, Arizona. They'll also be in Munich in November. And the conference very much works to bridge the gap. So, we have that operationalization track, but we also have use case track and a very technical track. There tends to be a lot of sharing and cross-pollination between these areas. And we're the first and leading conference that is focused on commercial deployment. So not a research conference, not an academic conference, but also a vendor neutral conference. So not run by one of the software analytics vendors, but rather really we've been running this conference in order to hold an important sort of central position in the industry, bridging across vendors, across solutions, and across industries.
Great. So any final thoughts on AI, machine learning before we wrap up?
Yeah, I mean, this is the best. This is the best of science. It's the coolest technology. The idea of learning from data. It turns out it's really valuable. Turns out we're not capturing that value nearly as often as we could, but there's no reason to think that's not going to change. This is sort of part of the broader scale adoption of new technologies. So is hype. In this case, the hype might be a little bit more overblown than it often is, because we have this tendency to want to sort of anthropomorphize the machine, and that's a lot of fun. But we'll get past these problems, and I do believe that we'll continue to improve the track record. And there is an incredible amount of success stories, even if it's a minority of cases, even if it's 20% of projects that actually successfully deploy. 20% of a lot of projects is still a lot. So there's been a great track record. As I mentioned, there's 185 mini case studies in the first edition of my first book, and that was 2013. So the stuff is only continuing to grow and grow importance in terms of the central role. This is what it means to bring the best of science to improving business.
Yeah, it's fascinating stuff for sure. Well, thank you so much, Eric, for joining us. Thanks for joining Sarder TV, and we hope you'll come back.
My pleasure. Thanks, Vishali. Yeah, I'd love to come back.
Thank you.